Hello everyone, welcome to AiS&x. Today we are going to see how we can predict the words from the previous passage or previous words with the help of deep learning, right? So of course, as we know, this is very much debate nowadays with generative AI and all of that. But in this, we are going to use simple machine learning and deep learning techniques to do such a thing on a data set that we have already taken into account. So let's get it started. The first thing that we need is we need to import a few libraries. So let's write import pandas as pd. After that, I'm going to import os because I'm going to need that later, and as well as the numpy library. So let's write import numpy as np. After that, I'm going to move on towards TensorFlow. So import TensorFlow as tf, right? And after that, I'm going to import TensorFlow.class.processing.sequence. So we need paired sequences from that, right? So from TensorFlow.keras, right, dot preprocessing dot sequence, import paired underscore sequence, right? So after that, we are going to need LSTM dense bidirectional and embedding layers, and we are going to import all of them from keras.layers, right? So from TensorFlow.keras.layers, import embedding, comma LSTM, comma dense, comma bidirectional, right? And after that, I'm going to need tokenizer. So let's bring that up as well. So from TensorFlow dot keras dot preprocessing dot text, import tokenizer. After that, we are going to import sequential and Adam. So sequential is available in keras models. So from TensorFlow dot keras dot models, import sequential. And last but not the least, we are going to import Adam. So for that, let's write from TensorFlow dot keras dot optimizers, import Adam. So let's run this. We have an error here. I was supposed to put dot here. So let's run this and let's see if we are able to bring in all the libraries or not. Okay, so let's see what is the error. So it's saying paired sequence is not there. Let's change it to sequences. Okay, optimizers, right? The same thing. Where is it? In the line 10. So optimizers. So let's do that again. And there we go. All the libraries are in this, right? So now we are going to import the data. It is available in the dictionary or the disk that I'm using. So I am just going to read it from there. So read underscore CSV, and in this I am going to write medium underscore data dot CSV as I am using that. So let's run that, and after that let me show you what is the data, right? So for that I'm writing data.head. So there we go. This is the complete data, right? URL, title, subtitles were available or not, image, claps, responses, reading time, publication, right? Through which we did the publication, right? So let's bring it. Let's write tail here and let's run this again. As you can see, now the publication, reading time, all of these changes with head or tail, right? So what is the next step? The next step is to see the shape of the data, which can be seen here that there are actually 6508 complete rows that are available in this data set, right? So it's starting from 0 and it's ending at 6507 or 08, you can say either, right? Other than that, you can also see that it has 1 2 3 4 5 6 7 8 9 10. So there are a total of 10 columns from here, right? 3 4 5 6 7 8 9 10, right? So these are 10 columns that are available. So let's suppose if we want to check the title that are available. So these are all the titles that are available in our data set, right? So next I'm going to make the tokenizer, right? So tokenizer is equal to, here I'm going to use the tokenizer that we have imported, right? And with only one change, that we are also going to use the OOV underscore token. So OOV underscore token is equal to OOV, right? After that we are going to perform the fitting. So for that I'm going to write tokenizer dot fit underscore on underscore text, right? And in this I am going to write the data that we have, right? And the title of the data. So we are going to use the title of the data and tokenize all the things that are available there. Okay, so after tokenizing we are going to say that the words count, so words is equal to length of tokenizer, right? So tokenizer, and then I'm going to write dot word index, right? So and add a 1 at the end, so which will get us the total number of words. So after getting the total number of words, we can just showcase the word index for different type of words, for total number of words, for consumption, for strong, for and any of that. Anyways, so after this what should we do next? We are going to take that input sequences is equal to empty, right? For example, so now what I'm going to do is I'm going to tokenize everything that is available in this data, right? So for that I'm going to write a for loop for line in data title, and after that I'm going to write list of tokens. Okay, so I cannot write this, so I'll write token list is equal to tokenizer dot text dot underscore to sequences, and in this I am going to write line, and after that I am going to write 0, right? So this is the token list, and after getting the token list we can of course print it out as well. So after getting the token list, what I'm going to do is I'm going to take another for loop for of course each line. We are going to do this. So for I in range, so what is the range? From 1 to length of the tokens, right? So let's write length of token list. So token underscore list, and let's do that, and let's get below, and now I'm going to write n-gram underscore sequence or n-gram sequence, whatever we want to say that, right? So n-gram sequence is equal to token list. So what I am doing is I am actually converting all of my words into tokens, right? And later I am going to append that into the input sequences, right? So input underscore sequences dot append, and in this I am going to write n-gram underscore sequence, right? And let's run this. It is saying that tokenizer is not something that is available, so for that I'm going to change it. So this is it, we have the input sequence now, right? We can print that out as well. So print out input underscore sequences. So these are all the input sequences that we have, right? So what is the next step? The next step is the paired sequences. Okay, so where are we going to get the paired sequences? So first we need to find the maximum sequence from all of this, right? So for that I'll write maximum sequence underscore length is equal to maximum of length of x, and for x in input underscore sequences, right? And after that I'm going to again write the input sequences. So I'm just going to bring that here, right? So I will change it to an NP array, right? And then use the paired sequences in that. Okay, and at the end I can just showcase you the input sequences that we have after that. So input sequences, let's do that after this. There we go. So now I can just write input sequences and show you the second one. Let's suppose. So there we go. As you can see, we have a padding at the end, right? So now the paired sequences has been added. What is the next step? I can add features and labels, right? So let's do that if you want to. If you don't, you can move forward as well. So what we are going to do is we are going to take the input sequences, right? And we are also going to take cross and get these labels, right? So after getting these labels, it is saying that total. There we go. So now what we can do is we can actually start making our deep learning model, right? So I would like to make a sequential model right here. So for that what I need to do is I need to first write model is equal to sequential. So model is equal to sequential, right? And after that what I have to do is I have to add multiple layers into this. So the first layer that I would like to add is embedding layer, right? So model dot add, and in that I'm going to write embedding, and after that on total underscore words, right? And comma 100 comma input length I'm going to give equal to maximum sequence length, of course. So maximum underscore sequence underscore length -1, right? And after that I'm going to add a by LSTM layer, right? So for that I will just write model dot add, and in that I'm going to write by directional and it will be an LSTM. Okay, let's write 150 here. After that I'm going to add a softmax layer, so model dot add. In this I'm going to write dense and total underscore words and activation is equal to softmax. Okay, so after that I'm going to write Adam is equal to Adam and with a learning rate of 0.01, and after that I'm going to compile the model, so model dot compile, and loss is categorical entropy, so let's write categorical underscore cross entropy, right? And other than that let's write optimizer is equal to Adam, and after that the matrix that we are choosing is the accuracy, so matrix is equal to accuracy. So after that I'm going to perform the fitting, so history is equal to model dot fit. I'm going to use the labels that we calculated before, right? So let's do this for 20 epochs, right? And let's make sure that we can also see something at the end. Let's print out the model. Okay, so it is saying that model compile is not, so there will be an equal to here. Total words is not defined, of course it is not total words, it is words, that's why. Okay, so it is again saying the same thing. Yes, in the dense as well there is words here too. Okay, so now it is saying that XC is not defined, so let's see what was this. It was XS, so let's change that to XS. So there we go, now it is running for 20 epochs, so it will take a little bit time. Actually let's just run it for 2 for now, right? And you can change the epochs whenever you want. So what will be the next step after this? After doing that, of course the results will get better as we increase the epochs, but for now what we will do is we will just show you the accuracy that we are getting with 2 epochs, right? Of course when the epochs are 50 or above, the accuracy will increase a lot. To showcase you the results, I have previously also ran it for 50 epochs, right? And I wanted to show you the results for 50 epochs. Of course for 2 we will not get the same results. So as you can see, it starts with something like accuracy of 0.08, right? And with time it starts getting really accurate, right? And at the end we get an accuracy of 85%, right? So this is the accuracy of this model that we are getting at 50 epochs. Of course if we increase it from 50 we can get even more than that, right? So this is it for today. This is how we can actually develop a model that predicts the next word from the sequence that it has before, right? So as you can see, it was a very good accuracy of 85%. Okay, so you can just get to 80 such as 50 epochs and check the accuracy by yourself, right? So until next time, if you want to see more videos like this on machine learning, deep learning and a lot of related topics, you can just watching AI Sciences. So this is a wrap for today.